Everybody. This is A.N. Mukundrao, along with Dr. R. Shrikant Swami, Electronics Department, Siddhaganga Institute of Technology, and we are presenting a paper on effective teaching learning practice adopted in signals and system course. First of all, let me thank ICTIE Organizing Committee and IUCE and SIT, without whose help this would have been not be possible. Let me go through the contents of this presentation. First, we have introduction, then literature review, objectives, methodology, effective teaching learning practices, evidence of success, finally conclusion and references. And this signals and system course, as all of us are aware of it, it's fully loaded with basic concepts, mathematical analysis and applications, and students find it very difficult to apprehend, understand and apply these concepts during their course. So it's very challenge for the faculty members also to teach this course, so the students can remember this for a long period. Long lasting and enduring understanding of this course is very important, as this course is a prerequisite for many engineering courses such as control system, analog communication, digital signal processing, image processing, speech processing, etc. So students have to understand the basics as well as they have to remember these concepts for a long period. So that's what enduring understanding is very important. So therefore, teaching SAS course effectively for these engineering students is a big challenge for faculty members. So what this paper deals is analysis the various level of difficulties generally students encounter while undergoing this course. So that analysis is made, and a systematic action plan is designed to overcome these difficulties of the students, and finally analysis of course outcomes achieved before and after implementing our effective teaching learning practices is presented. Signals and system course consists of basically classification of signals, elementary signals, and operations performed on signals, LTA systems, convolution, solution to difference equation, Fourier representation, and its applications, Z transform, unilateral Z transform applications. So these are the basic contents of our signals and system course. And this course content, course outcomes, topic level objectives, lesson plans are designed to meet the program outcomes. So this course is going to meet some of the program outcomes. And University of Texas at El Paso, they have also come up with some idea of, and they have discussed in their paper the technology based solution for teaching signals and systems, like connections, interactive simulation tools, usage of quad-based system, OpenStack tutor on continuous time signals and systems. So they have created problems with associated solution in the quad-based, and they have developed some interactive simulations in Mathematica, and students more effectively learn these concepts. That's what they claim. And they used assessment systems provided by OpenStack tutor to track and evaluate students' progress. This is what they do in University of Texas. And in Griffith School of Engineering, there's a paper on chalk and talk, which is most effective way of teaching signals and system rather than using PowerPoint presentations. And they, through their experience, they claim that this is what is more effective way of teaching, old conventional method of chalk and talk. And there is another paper by Richard and Nicholas. They discuss the importance of combining outcome-based learning and assessment. It emphasizes on use of simulating tools, assignments, project based on concepts of these courses. And objective of our work is basically students, as we all seen, they face a lot of difficulties in understanding, applying the concepts in signals and system course, and also they find it very difficult to remember some basic concepts. Uh, so the first objective is to identify these difficulties encountered by the students while learning this SAS course, and secondly, to use some innovative methods to address each one of them. So what are the advantage or benefit of these is they learn the subject in depth, so analyze the signal processing challenges so that they can solve real-time projects. They can apply these concepts to solve real-time projects. They can apply these concepts in other courses as well as in their coming semesters. So how we actually have gone through this is, we have first identify the difficulties of the students normally they encounter. So we have identification method to identify their difficulties. Then we categorize these difficulties, and we address the difficulties of each category with effective teaching learning practices. So identify the difficulties, categorize them, and address them. How we identify the difficulties the student is, prior to this 2012, we have assessed the performance of some students, and there are 170 students in each year in our institution taking signals and system course, and we have analyzed the CIE semester end examinations, quiz papers, assignments, and then we have categorized what kind of difficulties they normally encounter. Normally they encounter memorize the difficulty in memorizing the formula. While using the formula for computing energy, power, Fourier coefficient, inverse Fourier quotient, Z transform, they find it difficult to remember these formulas. And then they find difficulties in solving the problems, like representing the signals by mathematical expression only they find it difficult. So performing integration, differentiation, geometric series, and by simplifying and adopting this time shifting, scaling, time folding operations, so they find it difficulties. We categorize this as problem solving difficulties. They encounter difficulties in problem solving skills. Then of course this convolution process is one of the major difficulties they encounter while sketching the signals and input signals, impulse response signals, and then folding, checking N and T intervals. Excuse me. So they find it difficult in this operation, and understanding the basic process of convolution is a big difficulty for them. And computing integration, summation, they find it very difficult here. And some students find difficulty in applying Fourier transform properties or Z transform properties to solve problems. Applying these Z transform and Fourier transform to find stability, causality of these systems. So these application finding, they find it difficult to apply these concepts. Also there are some conceptual mistakes they go through. They have a lot of confusion in continuous and discrete time representation, periodic, non-periodic signals. While taking the mathematical expression for periodic and non-periodic signals, they find it difficult. There will be a lot of confusion in time domain and frequency domain operations. Confusion with impulse response, frequency response. So these are the normal conceptual mistakes they go through. And analyzing the stability, causality of the system in terms of poles and zero. This is also the difficulties of some of the students. Sketching the spectrum of the sample signal, example, aliasing concepts. If we take a signal and if we sample it in one domain, how the spectrum varies in other domain. Normally students find it difficulty to understand this also. So we have a tabular column way representing this. So here we have put that mistakes committed by the students, different types of mistakes, and then we have categorized them. So problem category 1, here we say memorizing the formula. So to calculate the energy, power, Fourier quotient, inverse Fourier quotient, basically they need to remember the formulas. And average around 20% of the students find it difficulty in memorizing these formulas. and we have this assessment through this file. So we have prepared an Excel sheet where we have taken a problem, a particular problem. Example, determine the energy of a signal. So a signal is given to them, and they are supposed to write formula and evaluate the energy of the signal. So students score in their students, this is a maximum score is marks is 6 marks, and this is the list of the marks students score for this particular problem. And then so this is the individual marks scored by them. And then we have identified how many of them have not been able to write the formula properly. So we have listed them here, and totally out of 10 students, out of 50 students, they find it difficulties or they made mistake while remembering the formula itself. So it turns out to be 20%. So this is how normally we have evaluated this. So this is what is the 20%. And then students, while representing the signal by mathematical expression, performing integration, differentiation, geometric series, simplification, and while performing time shifting, time scaling, they also, they make mistakes here also. So we have taken another problem here, another question here. And this is a signal, and the question is find the even and odd parts of the signal. And this is a list of the, this is the marks scored, the maximum marks is 6, and these are the marks scored by the different students. And we have identified here the mistakes, how many of them have scored less than 2 out of 6. We have made them, we have counted them, and that comes out to be 11 out of 50, so that is 22%. So this way we have actually identified and we have listed what are the percentage of students make mistakes, how many students will make mistake in representing the signals by mathematical expressions, have 18%, differentiation, integration differentiation difficulties 25%, and then we have taken average of this, and we call them as problem solving skill. The students have difficulty in solving the problem, so that is around 22%. Then students normally find it, as we have already seen, convolution process. During convolution process, a lot of people will make around 15% of the students may make in sketching the mistakes in while sketching the signal itself, and around 25% of the students will make mistake in taking the range, N range, T range graphical method of doing convolution. So that's how it comes out to be an average of 20%. 20% of the students make this mistake in convolution process. So similarly, we have taken statistics of the students who make conceptual mistakes. So we have identified these are the mistakes as a conceptual mistake: confusion in continuous and discrete time representation, confusion in time domain and frequency domain representation, impulse and frequency, causality, identifying, justifying stability and causality of a system. So a lot of students make mistakes in this. So that's around 16%. And applying these properties of Z transform and Fourier transform in solving the problems, that's around 25%. So we have first statistics of all these things. So after taking the data and analyzing them, then effective teaching learning practices are devised to overcome this. So considering the difficulties students generally encounter, teaching learning practices are actually adapted. Ideally, these are adapted irrespective of the faculty in charge. Whoever may be the faculty and maybe whatever may be the quality of student intake, the activities or the teaching learning practices we devise should nullify those effects. That's the main idea here. So this is the chart we have actually, teaching learning design. So as all of us know that students learn 10% of by reading it, and by hearing they learn around 20%. So this is the chart, learning activity. Through this learning, read, hear, see. These are passive learning. Read, hear, see and hear. So they learn around 50% of this through these activities, whereas the majority of their learning takes place through active learning, through what they do, what they write. So keeping this in mind, and higher level learning outcome such as analyze, create, evaluate, can be achieved through this active learning. So keeping this in our mind, the teaching learning practices we have devised. So these teaching learning practices we adopt in signal processing, signal and system course is we conducting weekly tutorial classes and building an animation, convolution animation, graphics, activity-based learning, remedial classes, utilization of mathematical tools such as MATLAB. So first we conduct weekly tutorial classes. So we first identify the bright student in this class to assist the faculty. So we consider their grades in engineering mathematics, and by seeing those grades will identify bright students to help the faculty member in conducting tutorial classes for the students. The class is grouped into batches of some 15 students like in lab, and tutorial class for each batch is conducted weekly. In tutorial classes, each student will solve the problems with the help of peer learner and faculty. The student, bright student, whoever has been identified, he has been given a problem well in advance, and he has been asked to come prepared on that day, and the solution is also verified by the faculty, and this student along with the faculty will help his other students to solve the problems. So there is an advantage, lot of advantage over conducting the tutorial classes like this. One-to-one attention is possible because the strength of the class is very small, and problems can be discussed with the students individually, and there is a scope to allow the students to solve the problem at their own pace. And more importantly, some of the students hesitate to talk to the faculty member about their doubts. They feel that it's very trivial doubt, so they hesitate to talk to the students. Whereas they feel it very comfortable to talk to their own peers. That means, so a student can easily approach to another student. So this it also helps us in solving the difficulty of the students. So this practice helps problems in improving the problem solving skills of the students and encourage them to learn from each other. Also, by assisting their fellow classmates, the students will also get their concepts strengthened. So basic concepts of the student, bright student who is helping the faculty member, he also get the advantage. And this is the image of the tutorial classes we have conducted. Here are some of the students, volunteers or bright students who are helping the faculty member. Then we have the second teaching learning practice, that is convolution animation. Here, since many students find performing convolution operation very difficult and they cannot understand that concepts or the process, so to enable the students to visualize the entire convolution process, convolution animation is developed to illustrate these concepts, and it is uploaded, and this is the link. And my colleagues, Dr. Srikant Swami, has developed this animation, and this is available on the net with this link. And now I will just show you. Yeah. So we have a signal, impulse response. It's a continuous time. Yeah. This is folding of the signal. So fold the impulse response and shift it. Then you can see that how the shifting and how this convolution output can be obtained. So the graphical representation of both impulse response input and final output will help the student to understand overlapping interval, n range, tau range, where students mostly get confused. So that how to take the ranges, intervals. So these graphics will really help the student. As another example, we have a couple of examples here. Yeah, this is the shifting of impulse response from minus infinity to plus infinity, how the overlapping interval takes place, and how this overlapping takes place, and finally the y of t, the response of the system for the given input. So these things definitely help the students to understand the convolution process. And by our experience, students really have enjoyed this, and they have started doing their own animation as well. There are some of the examples of discrete time signals. Yeah, this movement, then formula. So yeah, so this is a animation, and this is the popularity of this on the net. It's shown here. And the third one, next one is activity-based learning. So in order to achieve higher end learning outcomes, such as analyze, create, evaluate, activity-based learning is developed. So technical quiz competitions are conducted, pick and speak or pick and sketch activities are conducted. These activities help students to strengthen their basic concepts. So their confidence level also increases. GD is also involved here, group discussion. So improves the soft skill, and concept retention rate also improves considerably because they are doing while learning. So these are some of the images in that, I mean, images of students in technical quiz competition. So this is example of some speak and sketch. So example, we will ask them to sketch a signal. They'll come and pick the chit, and then whatever signal they get, they have to sketch that signal. So students will ask to sketch certain signals, and the others will do that speak and sketch. And remedial classes, to boost the morale of slow learners, remedial classes are conducted. Here students are taught easy way to memorize the formula, and they are encouraged to ask some questions, thought-provoking questions. The students are encouraged to solve the problems in different approaches, and variety of problems are also solved in remedial classes. So the learning becomes easier, and problem solving skill also improves. Problem solving skill improves, confidence level also increases. Hmm? Connection. Okay, students' confidence level increases, and they will be, I mean, very happy to face examinations with this preparation. And finally, we have effective utilization of mathematical tools such as MATLAB is also implemented here. So, effective utilization of MATLAB tool. Here, students find difficulty in representing especially complex signals, spectrum, poles and zeros, how to find the causality and stability of a system based on poles and zeros, and what happens in the spectrum when the signal is sampled in the time domain. So certain issues they find it very difficult to understand. So we have a mathematical tool here, and a small code is developed, and this code is run and shown them the graph. So this is a real value exponential signal. So real continuous time, real exponential signal, and this is the complex value signal. So here the real part of the complex signal, a small MATLAB code is developed here, and we are showing them the real part of this, and imaginary part is and magnitude, phase. Interestingly, we can show them that here is the signal actually, and this is actually the slope of the signal, e to the power of j 0.3. So this is becomes the slope, and you can see the slope of this signal phase. here, and it is 3 by 10.3, so they can match. We can help them to understand magnitude, phase of a complex signal. And this is spectrum of a composite signal. Here we have taken example of three sinusoidal signals of 50, 100 and 250 signals, and we sampled it at 1000. So this is the composite signal, representation of the composite signal. If the more than one signals are added, how the signal looks like, and this is spectrum of that. They can see that here it's a 50, 100 and in 250. These are the message signals, and this is because of the sampling. So they will get at fs minus fm1, yes, fs minus fm2. So since fs is 1000, we can show them that 1000 minus 50, that is at 950, they will get one component, and 1000 minus 100, that is at 900, and finally 1000 minus 250, that is at 750. So we can help them in understanding the spectrum representation. So by sampling the signal, the spectrum repeats. We can help them in understanding these concepts. Similarly, we can help them in understanding pole zero representation, which students at third semester level, especially signal system, find it a little bit difficult. We have taken example of first order LTE system. So y of n is equal to x of n plus 0.5 y of y in n minus 1. Here is a small MATLAB code that depicts the zeros and poles of the system here. Okay, this is 0, this is the pole I have labeled here. Okay, this is the pole, this is a 0, this is the unit circle, and we can see that if they take the z transform of that, they will get is a 1 by 1 minus 0.5 z inverse, or z by z minus 0.5, and by that they can see that the pole is located at 0.5 and 0 is located at origin. So this, they can do it mathematically here, and they can see it through graphical representation. A small code like z plane b comma a, this will achieve that. So they understand the location of poles and zeros here. And by showing this, we can also tell them that since 0 is within the unit circle, the impulse response of such a system is basically a converging signal, 0.5 to the power of n u of n. It is basically a exponentially decreasing signal. So this we can tell them. It's because pole is inside the unit circle. And this is how. Same take an example of the same first order LTE system here, and we can show that the impulse response of this is discrete and it is continuously, I mean, it's a decaying signal. And this is the frequency response of this, magnitude and phase of the frequency response, and we can show that. And by these activities, these teaching learning practices, actually memorizing, the conducting tutorials, remedial classes, convolution animation, activity based learning, and mathematical tool, these difficulties, whatever we have identified, can be mapped actually. Each difficulty here is addressed by at least a couple of activity teaching learning practices. Example, memorizing the formula. The difficulty of memorizing the formula is addressed by conducting weekly tutorials as well as conducting activity based learning. So this teaching learning practice will address this issue of memorizing the formula. Similarly, problem solving skills is addressed by tutorials as well as remedial classes. Convolution process, by conducting remedial classes where one-to-one communication is possible, and also by going through convolution animation, this convolution process, the difficulty can be addressed. Similarly, conceptual mistakes can be looked at by activity-based learning. Here, students learn and remember the things very easily. So, applying the concepts. So, concepts, properties they have learned can be applied to solve the problem. So, activity-based again, and MATLAB tool, using this MATLAB tool, these difficulties are addressed. So, at least each teaching learning practice will address is going to address these difficulties we have identified earlier. And this is the evidence of result actually. So this first bar indicates this students before implementing these teaching learning practices, 20% of the students have a difficulty in memorizing the formula. So this is through the analysis of the data through Excel sheet, and the 20%. And after implementing it in the next immediate year, first year, that has come down to around 18%. So subsequently it has come down to 15%. So there is a decrement here. I mean, there is a reduction in difficulties, memorizing formula difficulty, and similarly here you can see that problem solving skill or difficulty in problem solving skills has the difficulty is reduced as the year goes by. This is because of the activities. So similarly convolution process, there is a decline here. So the difficulties of the students have reduced. And applying the concept, this most of the students make mistake here. 25% was the percentage of making mistake earlier, and it has also come down drastically. So this is academic success. So percentage of students committing mistake, different problem category has been declined since the introduction of effective teaching learning practice. It is also encouraging that the number of overlapping, the number of students committing different category of mistake is reduced. Overlapping number of students means same set of students will make mistake in more than one problem category. That is also has come down, and this has resulted in improvement of results of SAS scores, and it is shown here. So this is the course outcome. So these are the course outcome we have listed in for signals and system. And before implementing this teaching learning practice, these are the various level of achievements by the students, D grade. And since the introduction of this teaching learning practice, it has been constantly increasing. I'll show you how we have evaluated. Again, we have taken a problem in whatever problem has appeared in final examination, semester end examination. This problem is going to map to the first CO. So see, it's a CO assessment. First CO is going. I mean, this problem is going to map to the first CO. So these are marks scored by different student in examination, and we have taken the average of this, and we have allotted a grade for this. We have calculated the grade, and according to that, 0 to 45 is considered as a D grade, 46 to 60% C, 61 to 75 it's a B grade. So students have, I mean, the attainment level is B grade for this particular course outcome because of this implementation. This is how we evaluate actually. So we take this average of all the marks scored by all the students, and we calculate the percentage. So this is in the CO2. It's analyze the property of the system in course outcome 2. Again, another problem is identified. So this is the problem to identify. I mean, is identified to map to that course objective, and this is the maximum mark system. Maximum mark system. These are the various marks scored by the different students, and this is a final total marks, and it is averaged, and A level attainment is A level. That means more students. So that's come under the category between 76 to 90% of attainment. It is 404 divided by 50. 50 into 10. 50 students, maximum is 10 marks. So it is 404 divided by 50. That is percentage becomes A. So this is how we have evaluated, and this is how we have listed. This is 2000, last column is 2015, and it is continuously improving. So that's a satisfaction. Here is actually there is one problem. Here is a B actually. So here is a declinement. This is a cost over. We have to see that part. Finally, conclusion. In this paper, a methodology to identify the common mistakes, difficulties students face while learning this course is divided. So that methodology is basically preparing an Excel sheet and identify the problem belong to that category, and list the marks scored by the students, and analyze that marks and find out how many percentage of students have difficulty in particular category. Then difficulties are categorized, and finally these teaching learning practice are identified carefully so that active teaching learning is going to take place and students are really benefited by this. And finally, we have put this, again we have taken the analysis of as the students' performance, and then we have done same exercise through Excel sheet, and we have observed that there is a constant improvement in the performance of the students. However, there is always a scope to come up with a new innovative method of teaching learning practices to achieve better results. These are the references I have seen. Thank you all.
Thank you, sir. We will give the audience 1 or 2 minutes in case they have any questions.